MacMaths. Let's do some maths today. Statistics. Okay, today, the lesson today, I'm going to show you how to calculate the variance and standard deviation and how to do it on a calculator as well. I'm not going to do the lesson support for exercise 2E. I'm going to call this part A. I'm going to do that just the questions in part B so that this lesson is not too long and you're not getting too bored. But I'm going to start off, if you're sort of new to this and you're wondering what the standard deviation is and the variance are, I'm going to try and explain how my brain sort of thinks about this. Okay, so here we go. This is how I think about it. Okay, so let's take some data that's been sort of spread out here. So these are all data points, sort of numbers sort of put in order. Okay, maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So if you take the median, okay, the median works on position. Okay, so it's the position of the middle piece of data. So it's right in the middle, isn't it? It's actually that bit of data. And what goes with the median is a measure of spread, so how spread out the data is around that median, around that middle number. And what we use for that is the actual range, don't we, for spread for this. So that's the gap between the biggest and the smallest, or we might use the interquartile range. So, and again, that requires us to find, you know, a position. Okay, let's write that word there, position. So the interquartile range is two positions that we find for 25% in and 25% back from the end. Okay, and this is your biggest and your smallest. Okay, and that's Q2, and that's right in the middle. So when we use the median, okay, the middle number, as a measure of spread that goes hand in hand with that is finding other positions. We've actually been looking at, you know, percentiles, haven't we? So we've been looking at, you know, maybe P80 and P20 in the other exercises before this, okay? So not just the quartile at 25%, but maybe at 20%, and maybe not just at 75%, but 80%. So the median and how we say how the data is spread out, we use positions, and we use quartiles and percentiles and so on. Okay. So what about the mean? So the mean is worked out differently. It's a different sort of average. Okay. So we get it by adding up all of these numbers and divided by how many there are. And it gives us, again, a sort of a middle-ish sort of number, but it's not the middle number, is it? Okay, it's a number that would sort of sit in this region here, okay, you know, at the heart of the data. That's what we really want. And we label it this sort of X with a little line over the top, don't we? Okay, so it seems inappropriate to me, or it always seemed inappropriate to me, to use as a measure of spread the range or the quartile, because the range and the quartiles is about positions, and that seems to be hand in hand with the median, that's positions. So mathematicians use something else. I don't know why they harp on about variance. They never seem to. It's meaningless to me. But I'm going to show you how to calculate it because it's connected with this fella here, the standard deviation. Okay, so the standard deviation is a measure of spread that is sort of based on the mean, as the interquartile range is based on the median, on positions. Okay, and what you tend to find out is that, just as a very rough general rule, when you work out the standard deviation, it's a number that tells you roughly how spread out the data is either side, or most of the data either side of that middle region, if you like. The bigger the number, the more spread out the data is. You usually find that most of the data is about sort of one standard deviation away, you know, from the mean. We'll look at that in a minute. And it's a way mathematicians tend to identify what they would consider as, or put rules on what they would consider as outliers. Okay, so this here on the diagram form, this may be like one standard deviation, you know, if the data is reasonably evenly sort of spread out. 1.5 standard deviations of that number would take us to about there, and half of that to about sort of there. And mathematicians often use 1.5 standard deviations to say that any numbers outside of 1.5 deviations calculated would be classed as an outlier, okay, from that words on, okay, and you might want to clean up the data and ignore those or whatever. We've talked about that. So the standard deviation is just a measure of spread that tends to go hand in hand with the mean, and you've got to sort of calculate the standard deviation and use it and comment on it a few times to actually get the hang of it, okay, and you know, it really seems really straightforward to understand the interquartile range, but the standard deviation, you've got to work it out and discuss it and compare it a few times on a few questions before you sort of start to get it, okay. So that's how I understand it, okay. Median and spread is median in interquartile range or range. Mean and spread, you mean and you use the standard deviation, okay. So let's look at what it is and how it's calculated. So let's get rid of our median. Now we don't need that anymore. We're looking at this mean, okay. So the mean and standard deviation, right, okay, so a few calculations here, okay. So let's have a look at the standard deviation. The standard deviation, oops, and the book will start with the variance. I'll talk about that in a minute. The standard deviation, because that's the main thing for me, has this symbol. I think it's sigma, but the lowercase sort of sigma, okay? So it's that, is it? I don't know what it is, okay? Has that little symbol, that little Greek letter symbol, forgotten what the Greek letter is, and it is equal to the square root of the sum of x minus x bar all squared over n, okay? Now, let me just explain what this is, okay? So x is your data, each one of these, so that's x1, x2, x8, those datas, minus the mean, okay? We know that, minus the mean. In other words, say that this one had a mean of 5 and that was 1, then x minus x1, it's got a gap, hasn't it, of that piece of data is 4 away from the mean, and that's what this calculates here. Now I know it might be minus 4, but when you square it, that's what squaring does, it just gets rid of the fact that some of these are minus, okay? So it's this here is the sum of the square of the difference of all of these numbers from the mean, okay? So if these numbers were like this, for instance, this here, if the mean is 5, okay, then this one we'd be doing 4 squared plus 3 squared plus, that's only 2a, so the difference is 2 squared plus 1 squared, and then this, if that was 6 there, plus another 1 squared, and if that was 7, so this is, you know, that's plus 2 squared because it's 2 away squared. So the sum of all of those, the squares of the differences from the mean, that's what this is calculating, divided by how many there are, okay? So let me show you an example, and let's work this out for a set of numbers. Let's keep it really simple. Let's just take 4 numbers. So if we take 4 numbers, now numbers these variables, we normally label them x. That's where x bar comes from, the mean of those numbers. So let's pick some numbers, and I'm just going to go with 5, 6, 7 and 8, okay? So 5, 6, 7 and 8, the mean of those numbers is going to be 6.5, isn't it? That divided by 4 would be 6.5, okay? So this here, the difference between the numbers, so x minus x bar, okay, for these, so let's work that out for each one of these. So bearing in mind that the mean is 6.5, this one, sort of, I'm doing it in a sort of table here. The difference here is 1.5, isn't it? That is 0.5 away. This one here is 0.5 away, and this one here is 1.5 away. Now, I know you're probably going, hang on a minute, 5 would be minus 1.5, but that's irrelevant because actually I could put in as minus and minus, yeah, I suppose I should really, but actually it is irrelevant because what you need for this is the sum of all of those squared, okay? So v squared is 1.5 squared, and 1.5 squared is 2.25, minus 1.5 times minus 1.5 is 2.25, okay? 15 squared is 225, oh, I think, 0.5, oops, so let's switch it on first, 1.5 squared is, yeah, 2.25. 0.5 minus 0.5 squared is 0.25, 0.25, and 2.25. And if we, the sum of all of those, that gives us our top line, x minus x bar all squared, is all of that added together. So that is 2.5 is 5, isn't it? 2.5, 2.5, and 2.5 is 5. Okay, so all of that is 5. The sum of x minus x bar squared divided by n, and there's 4 numbers, is equal to 5 over 4. Now this here, at this point here, is the standard deviation squared, isn't it? Because the standard deviation is the square root of all of that. And this here is what mathematicians call the variance. So there you go, we've done that now, and that's done and dusted. Why you ever need the variance, I don't know. I don't know why it's referenced. They use it as a measure of spread, but it never really is, because people don't talk about the variance. They always go on to work out the standard deviation. But that's what the variance is. It's just the standard deviation squared. Okay, so 5 over 4 is that, and then the standard deviation is the square root of that, 5 over 4, and if we square root that, the square root of 5 over 4 is equal to 1.1, 1.118, so 1.12. Okay, now have a look at that now. That's the standard deviation. And just think about what I said before. When we've got these 4 numbers, 5, 6, 7 and 8, evenly spread, there's x bar, 6.5 in this case. You imagine one standard deviation, if you add 1.12 to that, it gives you 7.6ish, doesn't it? It goes up to about 7.6 and down to 5.4 ish. Okay, it's like the sort of the interquartile range, isn't it? You can see it's close to that, and it's close to this one. It's just sort of inside of those limits now, and it gives you an idea. 2 standard deviations is going out, that anything outside that would be classed as outliers. Sometimes mathematicians might say 1.5, so 1.5 lots of that either side. Any data that falls out of that within our data set would be classed as outliers. So it's a measure of spread, and you get used to thinking about how spread out data is and how it isn't by doing lots of questions and getting used to standard deviations. Okay, so that's what the mean and the standard deviation. I know it looks complicated, the formula. Okay. There is another way of calculating it though, and actually when you've got lots of numbers, it's an easier way of calculating it. So let's just hold this to one side. We've got sigma is equal to 1.12, haven't we? Okay. quite often that's the formula, but there's an easier way of calculating than that. Okay, and well, there's two easier ways of calculating. Also works the same as that, okay, is the square root of the sum of x squared divided by n minus the mean, the sum of x over n squared. Okay, so that is those numbers squared divided by 4, the sum of those numbers squared divided by 4, minus, and this of course is the mean, isn't it? Okay, the sum of all of those divided by n squared, so that is the mean squared. Or I suppose you could better write it the sum of x squared over n minus the mean squared. Okay, so it gives you the same answer as this. So let me just show you that that works. Okay, so we just shifty those along. X is 5, 6, 7, 8. 5, 6, 7 and 8. Okay, x squared is 25, 36, 49 and 64. And it saves you doing any of those all those individual takeaways. If you've got lots of numbers, it was easy for mine because there's a symmetry about this, but if you had lots of numbers, doing all of those, working out the mean and doing all of those takeaways would be a pain in the backside. So this, when you've got awkward numbers, this is much easier. You just square all your numbers, so you've got all your numbers squared. Okay, and then we want the sum, we want the mean, don't we? We've got the mean, sum of x divided by n, so the mean was 6.5. So mean is 6.5, we've got that. The sum of x squared is just those numbers added together, so let's do that. So 25 add 36 add 49 add 64, that gives you 174. Okay, and now, so we want the square root of 174, sum of all of this divided by 4, minus 6.5 squared, the mean squared. Okay, so let's do that on the calculator all in one go. The square root of 174 over 4, I don't know if you can see that, okay, minus, what was it, 6.5, the mean squared. There you go, I've just put those numbers in to my calculator. I'm going to press equals, it should give me that 1.12, which it does. Okay, the same as what we got there. Okay, so that's what, you can use that formula, that's the one I was taught at school, but mathematicians use this here, this version of it, okay? And the variance, remember, is just without, I don't know why you would use that, it's just that squared. It's 5 over 4, okay? Sometimes you're given summary data, okay? So summary data in a question, they may tell you, they may work this out for you. So they might talk about summary data and give you that figure. Great, saves you doing it, doesn't it? Squaring them all and adding them all together. They may give you the mean, or they may give you the mean square. They may go, this is that. So if they give you that, all you're doing is really sticking those two numbers in, aren't you? Dividing by 4 and square rooting, okay? Sometimes they give you this capital S, just be aware of this for summary data. And if they're talking about variables that are labeling X, they put 2 X's there, okay? If they give you that, and I don't think they do in the first exercise, in exercise 2E, okay, that is referring to this, okay, all of this. In other words, it's the sum of the difference between your values and the mean all squared, okay? So that means if you divide that by how many bits of data, you've got the variance, which is obviously the standard deviation squared, would be the SXX over n. So all you've got to do then is divide it by how many bits of data you've got, and the standard deviation would be the sum of SXX over n. So sorry, if you come across that, you have to remember it. I've just had to learn it to teach it to you now, so, and it's stuck now because I've gone through it twice. Okay, so you may be given that, and in fact you are later on in the exercise. So when we do the coding, that crops up, so I'll talk about it again. Okay. And finally, I might as well take the opportunity now just to show you this as well, because if I rub all that out but I just leave this on here, okay, you can, if you look, you need to get one of these calculators. I did flick through and I saw in the exercise that I'm going to go through in the next lesson, it does say work it out on your calculator. Okay, so here I go, half an hour later I'd sussed it out. Okay, so what you'll need to do on your calculator is you'll need to press menu. The little graph here, so if you just scroll along to your graph until you get statistics there. Okay, I hope I remember this now because I've literally just worked it out. So you press 6, okay, and now you're into statistics. You want the one variable, okay, so you press 1 to give you that, and it gives you this table here. Now the variable, your x's are your numbers here, so let's put in 5, 6, 7 and 8. So all you do is you put 5, press equals, and it just goes down this column here. The frequency, there's only one of those, so this allows us to put in a table. If it was a table and there was 7 of them and 15 of them, we could scroll across, but put those in second because it automatically goes down for you. So I'm going to put 5, 6, press equals, 7, press equals, and 8. Now you might think that it only goes up to 4, but it just keeps going if there's more data. And there's only one of those numbers there, okay, so it just automatically puts 1 in for you unless I wanted to change that. So I've put those numbers in now. If I scroll back up, you can see I've put in, oops, there, 5, 6, 7 and 8. Those are my 4 bits of data. And all I go now is I press the options button, okay, and one variable calculations. That's what I want, the one variable calculations. And I think that was it. You press 3, okay, and it gives you all that summary data. Okay, so press options, and on your calculator, I'll show you that again in a second. You press options and then you press the one variable calculation. That's the one you want. You press the number and it just goes to it, and there you go. If you look at that now, can you see that top row? The top row, it's got X bar there. Trying to keep that still, and it tells us the mean was 6.5. We know the sum of all of those numbers. Look, the sum of x, all those numbers add up to 26. It tells us that is the next one. The sum of x is 26. It gives us the sum of x squared. If we wanted that, 174. You remember I worked that out, didn't I? The sum of x squared, and there it is. The variance is 1.25, and you've got that little sigma x there is equal to 1.118 blah blah blah, and that's what I rounded off, isn't it, to 1.12. okay, so you can see it works. Alright, and that there s squared x, don't know what that is. You'd think it was that summary data, but it doesn't seem to be. Okay, because if you divide that by 4, it doesn't give you the variance squared, so I don't know what that is. If you know, you can message me and let me know. Okay, I'll go and ask my daughter. She seems to think she knows everything. Okay, alright, so that's how you do it. That's the formula that you use. That's how you do it on a calculator. When we go through the next lesson, I'm going to just go through the exercise, so that will get you used to those, so you can try and do it on your own and you'll forget, and then you just watch the next video as I go through those questions. Okay, so that is standard variance and standard deviation, okay, that you need to be able to calculate from data that they give you. All right, over and out.